Hello and welcome back. In this session, we are going to learn to symbolize categorical proposition and how to draw them as Venn diagrams. So let's begin. Now here are some basic points which you should understand before you start drawing the categorical propositions. We remember that the notion of empty class is very important in the Boolean interpretation of categorical proposition, and the empty class is represented by the symbol 0. That is, there are no members in the class, meaning we are going to designate that with the 0 symbol. Now, to say that a class is designated by the term S has no members, we will write an equal sign between S and 0. That is, when we are trying to say that S has no members, what we will do? We will write S is equal to 0. And to assert that there are S, that is, it is not 0, there are members in the S class, then what we will do is we will write S is not equal to 0, and the denial sign is depicted like this. There is a slanting line going in between the equal to sign, which means S is not equal to 0. And the standard form of categorical proposition refers to two classes, if you remember, S and P, which is the subject term and the predicate term. So where each of the two classes is already designated by a symbol, the class of all things that belong to both of them can be represented by juxtaposing the symbols for the two original classes, such as SP. Now see, all dogs are mammals. In this proposition, the two classes are dogs and mammals. They are two separate classes. Now we are going to represent the class which is both a dog and a mammal. So if dog was S and mammals was P, then to represent the class which is both dog and mammals, we are going to write them together as SP. This is the common part or the common membership of the two classes, and it is the product or the intersection of the two classes. Another point is to represent the complement of the class dogs. You remember we did complement while we were learning about obversion. Now, the complement of dogs will be non-dogs. So if dogs is S, then the complement non-dogs will be S bar. It is written as capital S with a bar on top. Similarly, the complement of the predicate term mammals will be non-mammals, and it will be written as P bar. The new notation permits us to symbolize E and I propositions as equations and inequalities. So let's see now what happens. Now let's begin by trying to symbolize a proposition. What is the A proposition? All S is P. What does it say? It says that all the members of the class S are also members of the class P. Now, in order to symbolize the A proposition, we first have to change it into its obverse. So, all S is P is equivalent to its obverse, no S is non-P. If you remember obversion, in obversion, the quantity remains same, but the quality changes. So all becomes no, and the predicate term is replaced by its complement. So P will become non-P, and these two are equivalent. So all S is P will become no S is non-P. And you have to remember that all E propositions say that the product of the classes designated by its subject and predicate terms is empty, that is 0. Therefore, the product of S and non-P, that is S and P bar, is always 0 in an E proposition. So the A proposition will be replaced by the equation SP bar is equal to 0. This is what applies to all E proposition, that is the product of the subjects and the predicate terms is always 0. So S P bar, S is the subject, P bar because it is non-P is equal to 0. Next is the O proposition. Here also we will first do a version of the O proposition. So some S is not P after a version will become some S is non-P. Some S is non-P is an I proposition and it is symbolized by the equation SP bar is not equal to 0. So hence the I proposition is symbolized as SP bar is not equal to 0. Now symbolization of the E proposition. No S is P. What does it say? It says that no members of the class S are members of the class P. That is, there are no things that belong to both the classes, which means the product of S and P is 0. This can be rephrased by saying that the product of the two classes is empty, that is 0. Because the product of S and P is 0, the E proposition is symbolized as SP equal to 0. So this is the equation for E proposition. Now the I proposition. Some S is P. It says that at least one member of S is also a member of P. So if there is one member, obviously it is not going to be 0. Okay, it means that the product of the classes S and P is not empty. So we are going to write SP is not equal to 0 with the inequality sign between 0 and SP. So you can see here how you're going to represent the categorical propositions. A is going to be SP bar is equal to 0. E will be SP is equal to 0. SP it will not be equal to 0 as far as I is concerned. And O proposition will be SP bar is not equal to 0. Okay, so now that we have understood the equation part, let's get into the diagrams. All classes are represented by circles. Now, if nothing is said about the class, either S or P, we are taking S over here as an example. If nothing is said about it, then it's a complete blank. So the first circle you see over here, which is of the class S, is completely blank. Now, if you're trying to say that the class is empty, that is, it has no members. For example, if you're saying that the subject class S has no members, in other words, S is equal to 0, then how will you draw it? This is the second circle which you see over here. You are just going to shade it. The circle which is shaded like this, we understand. What do we understand from it? We understand that this class has no members. And the third circle which you see over here, what does it say? It says that there is at least one member in the class, and we are going to put an X in the interior of the circle. Just one X, not completely full of X's, just one X, and which will tell us that S or the subject class is not equal to 0. Now the single circles will only represent the classes. But in a categorical proposition, two classes, the subject class and the predicate class, are interlinked in a proposition. So the circles are also going to be interlocked and intersected like the way you're seeing in the first diagram. Now concentrate on the red part of S which is not overlapping with P, that is the blue circle P, and it is outside the blue border. And it is written here, there, SP bar. What does it mean? It says that it is the product of the subject and also the product of not P. So it is written as SP bar. So what does SP bar signify? The part of the circle labeled S and does not overlap the circle labeled P. It diagrams all the S's that are not P's and can be thought of as representing the product of the classes S and not P's, and therefore this portion is labeled as SP bar. Okay, now look at this middle part where the two circles are intersecting. What is written there? Just SP. This overlapping part where the two circles are intersecting, it represents all the things that are common to both S and P. Therefore, it is labeled as SP. Now the second one, you have to concentrate on the blue portion, the blue circle, the P circle, which is outside the red border. It is written S bar P. So it means the part of the circle labeled P and it does not overlap the circle labeled S, and it signifies all the P's that are not S, that is S bar, and it consists of the product of not S's, that is S bar and P. So it is labeled as S bar P. Okay. Finally, you will see outside the two circles, it is written S bar and P bar. What does it mean? S bar and P bar means all the things that are neither S nor P. So the fourth class is represented as S bar, P bar. Now this, with all the symbolisms and labels inserted, now the whole diagram will look like this. And this diagrams of this kind are called Venn diagrams. So Venn diagrams can be used to represent classes as well as propositions by shading out some places, or by inserting X's in various parts of the picture. We can accurately diagram any one of the four standard form categorical propositions. Now how we are going to diagram the A proposition. Just remember the equation. The equation for A proposition was SP bar is equal to 0. And now remember, where did we write SP bar in the interlocking circles? We wrote SP bar in the region of S, which was outside the border of P. So we are going to shade that part to represent SP bar is equal to 0. To diagram the E proposition, no SSP, we are going to symbolize this middle part and shade it. Remember that SP was the area which was in between the intersected part of the two circles. So we are going to shade that area of SP, and that is going to represent the E proposition, which is SP is equal to 0. Now in both the cases, A and E, the equation says that it is equal to 0. That is, there are no members, and because the product is 0, that is why we are shading both the areas in A proposition and also in E proposition. We will see that in the particular propositions, both the propositions are affirming at least one member. So both the particulars will not be shaded. They are going to be represented by X. So let's find out how we are going to represent the particular propositions. To diagram the I proposition, some S is P, symbolized by SP not equal to 0, we insert an X into the part of the diagram that represents the class SP. Now, which portion of the interlocking circles represented SP? The middle portion, which is common to both the circles. So that area is SP, and that SP is not equal to 0. It has at least one member. So in order to show this, we are going to write X in that area of SP. And the O proposition, some S is not P, is symbolized by SP bar is not equal to 0. Now, which is the portion of SP bar in the interlocking circles? The red circle and the portion which is outside, and it is outside the blue border. That area is SP bar, and that area is not empty. So we are going to put an X over there. So that will be the representation of the O proposition. SP bar is not equal to 0. Now what will happen if the subject becomes P and the predicate becomes S? We are basically going to follow the same procedure. Then the A proposition, all P is S, will be represented as PS bar is equal to 0. And which is the area of PS bar? PS bar will be the area of P which is outside the red border. So that area you can see is marked as PS bar, and since it is equal to 0, that is why that region is shaded. What about the O proposition, some P is not S? Now some P is not S is also represented by PS bar is not equal to 0. And the PS bar portion is also the portion of P which is outside the red border of S. And since it is not empty, we are going to put an X in that area. The E proposition, no S is P, is logically equivalent to its converse, no P is S. So there is nothing to be drawn afresh. We have already done it. Similarly, the I proposition, some S is P, is logically equivalent to its converse, some P is S. And since we have also done that, that is that Venn diagram of some S is P, we need not do it again. So I hope you have understood how to draw the Venn diagrams as of now. Now let's do some practice. All physicians licensed to practice in this state are medical school graduates who have passed special qualifying examinations. Now, what you're supposed to do with this proposition, you're going to represent it with the help of Venn diagram. So, first of all, when you're getting a proposition like that, you have to symbolize the proposition with class names. So the subject class is physicians licensed to practice in this state can be symbolized as P because physicians start with P. And let the predicate term medical school graduates who have passed special qualifying examination be represented by the term, by the letter M. So now, after symbolization, the proposition becomes all P are M. This is an A proposition, and A proposition's equation is PM bar is equal to 0. After doing this much, you are going to draw two interlocking circles. P is going to be the subject, that is one of the circles is going to be P and the other circle, the predicate class, will be M. Then you're going to write PM bar in the portion of P which is outside of M. You're going to write P bar M or MP bar in the portion of M which is outside of P, and you're going to write PM in the common area between the two circles. Now you're just going to shade the area where you have written PM bar. That area is equal to 0, so it is going to be shaded, and this is how this will be the diagrammatic representation of the proposition which has been given to you. Now let's discuss these solved examples from your textbook. No shopkeepers are members. This is an E proposition. Shopkeepers have been represented with the letter S and members as M. So it becomes SM is equal to 0. The position of SM will be in between the two circles, that is the common area of the two circles. That area is SM and it is 0, so it is going to be shaded. The next one is also the same. Modern paintings. This subject term is represented by the letter M, and the predicate term photographic likenesses of their objects has been represented by the letter P. So it becomes MP is equal to 0. The region of MP will be the common intersecting area of the two circles, and that area is going to be shaded because it has got no members. The next one is an I proposition. Some patients exhibiting all the symptoms of schizophrenia have bipolar disorder. The subject class patients exhibiting all the symptoms of schizophrenia has been symbolized with the letter P, and the predicate class bipolar disorder have been replaced by the letter B. Okay, now this proposition can be represented as PB is not equal to 0. So what is the area of PB? It is again the common area in between the two circles P and B. And because it has got at least one member, so it is not going to be shaded. It is not 0. So we are going to write an X in that common area. The last one, all pornographic films are menaces to civilization and decency. This is an A proposition. Pornographic films is represented by the letter P. Menaces to civilization and decency is represented by M. So the A proposition's equation will be PM bar is equal to 0. Now, what is the area of PM bar? It is only that much which is outside the circle M, the border of the circle M. It is only that area which is PM bar, not the common area which is also shaded here in this photo that I have taken from the textbook. So you can see that I have put a big cross over there. This is not correct. You are going to shade only that area which is PM bar and which is lying outside the border of the M circle. So this is just a reminder that not all given answers are printed properly in your textbook. Just keep that in mind, okay? So with that, we are going to end this session. In the next session of logic, we are going to get into categorical syllogisms. That is, properly we are going to deal with the arguments. Till now, we were only dealing with the propositions, and now we will be getting into syllogisms. So don't miss that next video. See you soon. Bye-bye.